Hello, this is Dr. Farivar for Econ 4400. In this video, we are going to look at p-values and how to find p-values for hypothesis test on a slope parameter of a linear regression. We define the p-values as the smallest alpha being the significance level of the test. So p-value is the smallest alpha for which we can reject a h-null. So we look at the h-null of our test. The smallest alpha for which we can reject our hypothesis is called the p-value. So p-value is a probability like the significance level of the test. This is also a probability. So we are usually faced with three options. Either our test is a right tail test, or a left tail test, or a two-sided test. For each of these three cases, we will look at how to find the p-value. Our first example is p-value for a right tail test. For a right tail test, the p-value is the area under the sampling distribution to the right of the test statistic of the test. So in order to memorize, if it's a right tail test, p-value is to the right of the test statistic. So this is important here. Here our important value is the test statistic. We have to have the test statistic for a test in order to be able to find the p-value. Test statistic, to remind you, was t, which is beta hat minus the hypothesized value of beta hat divided by standard error of beta hat. So we need this number first in order to find the p-value. Then we go to the distribution, sampling distribution curve, and look at the area to the right of this value in order to get the p-value. If we are looking at the left tail test, the p-value is the area to the left of the test statistic. So we calculate the test statistic, the area to the left of that number would be the p-value for a left tail test. And for a two tail test, both of those areas we need to consider both. So the area to the right of the positive absolute value of the test statistic and the area to the left of the negative absolute value of the test statistic. Together, those two areas will be the p-value for a test. So let me show this to you in a couple of examples. The first example is for a right tail test, and we are testing for the effect of education. Our model is a model for returns to education. So our model would look like this. We have the wage, which is equal to beta 0 plus beta of education times education plus other factors in the model. Now we are testing to see if the effect of education on wage is larger than 45 or smaller, equal than 45. This is a right tail test because our alternative is giving values to the right side of 45. Let's do the test at 5% significance level. This is the estimated value for our model. X1 is the education here. These are the standard errors for us. And the t ratio. In order to keep the t ratio, we are looking at beta hat for the education. So x1 here was the education variable. So this is the beta hat. 45 is the hypothesized value, the value that we used in our h-null and h-alternative. And standard error of beta hat for us is 8.222. If you calculate this ratio, this will be approximately 0.2 0.202. So I have the t-ratio. Always remember, t-ratio is essential to find the p-value for a test. Now go back to the p-value. This is a right tail test. P-value would be the area to the right of this number. So if this is my graph, 0.202 will be somewhere here close to 0. To the right of this value, look at the area, this whole area would be the p-value for this test. Now let's look at the left tail test. I changed the hypothesis so that it represents a left tail test. You can see that H null is now beta smaller than 45. I keep the rest of the information the same. The t-ratio would be the same because we have the same value for beta hat, the same value for hypothesized value of beta, and standard error is the same, so 0.0202. That's the same t-ratio. Now this is a left tail test, so I'm looking for the area to the left of the test statistic. So on the graph, again, 0.202 would be here. Now the p-value would be the area to the left of this. So this area now is the p-value. It's to the left because our test was a left tail test. For a two-tail test, same example. The test is changed, the hypothesis is changed so that it is a two-sided hypothesis now. Our alternative has values to both sides of the hypothesized value. The rest of the information is the same. We have the same t-ratio of 0.202. P-value is the area to the right of positive 202 and to the left of negative 202. So we are looking at this area and also to the left. So both of these shaded areas together will constitute your p-value. So these two together are the p-value for this test. Now, how you calculate the area, that's a different story. We need solvers to calculate the areas for us. But if we want to show that on a graph, this is how we get the p-values.